Okay, section 7.2 is on solving quadratic equations by factoring. So before we get into solving quadratic equations by factoring, I'm going to review a few of the factoring rules. So the first one is the greatest common factor. So that's the first rule of factoring, is to always check for a greatest common factor. So we'll just do a few of these examples down here. So for the first expression here, if you look at the numerical part, there's a common factor of 2 that can be taken out, and both of them have an x term, an x squared and an x, so the one that's common to both would be x. So that would be put outside of the brackets, kind of, and you just basically say the first term, if you divide out the 2x, you'd be left with a single x, and the second term, if you divide out the 2x, the GCF of 2x, you'd be left with just a 2. And you can just do a quick check to see if you did it right by multiplying 2x times x, and you'll get the 2x squared, and then 2x times 2, and you'll get back the 4x. So you know that what you have left, what you have there will multiply to give you what you started with. Alright, so we look at the second one, look at the numerical part, and normally what I would do is, if it starts, if the first term is a negative, then factor out the negative. Okay, so the first term there, I'm going to take that negative out, even though it's not in both terms. I usually take that out with the GCF, factor out the negative with the GCF, right? So then, if you look at the numerical part, 6 and 36, 6 goes into both of those numbers, and out of the x parts, x is a common factor of both of those. So negative 6x squared divide out the negative 6x will leave you just a single x. And then 36 divided by negative 6 is going to be minus 6, and the x is already there. Typically when you factor out a negative, the signs of what's left inside change. Number 3, if you look at both of those, a negative comes out, and a common factor of 5x. So if you take the first term and divide out the negative 5x, you'll be left with positive 2 and x. And then if you factor out the negative out of the second term, you'll be left with plus. 25 divided by the 5 would be 5. And again, you can just do a quick check of multiplying through to see that you will get negative 10x squared minus 25x if you multiply that negative 5x through again. The next one, if you look at them, not all of them have x's, so the only thing that can factor into all of those numbers, or any greatest common factor of all three of those terms, would be the number 2. So 8 divided by 2 is 4, 10x divided by 2 is 5x, and 6x squared divided by 2 leaves you with positive 3x squared. Alright, the other type of factoring that you need to review is factoring trinomials of the form x squared plus bx plus c, where the leading term has a 1 in front of the x squared. So these ones here, you basically can just go straight to your factors if it's factorable, and the first terms will always multiply to give you what's first, so that would be c, and c would have to multiply to give you c squared. And what goes in here would be the two numbers that goes in here, have to be two numbers that multiply to give you the last term, which is 21, and add to give you the middle term, which is 10. So if you think of the factors that multiply to give you 21 and add to give you 10, it would be 7 and 3. So those would be the factors here. C plus 7 and c plus 3. And if you do a quick check of multiplying those two binomials by each other, you will get c times c gives you c squared, and then if you distribute the c to the next term, it would be 3c, and then distribute your 7 to both terms, plus 7c plus 21. Put that together, it will give you c squared plus 10c plus 21. So you know you've done it right. Okay, so the next one there again, if this is factorable, it's a trinomial that has a leading coefficient of 1 in front of the squared term, so you can go right to the factors. A times a will give you the a squared, and now you're looking for the two numbers that go in here would be the two numbers that multiply to give you 36 and add to give you negative 12, which would be minus 6 and minus 6. And again, if you multiply that out, you'd get a squared minus 6a minus another 6a plus 36. So you know you've got the right factors, because it will give you the a squared minus the 12a plus the 36 that you need. And all I'm doing is just basically, if I just go back up there to show you where I got that from, it's just a times a is a squared minus 6a plus 36. Alright, next one again, if it's factorable, the two terms will multiply, x and x will multiply to give you x squared, and the two terms that go in here would have to multiply to give you a negative 28 and add to give you a 12. So if they multiply to give you negative 28 and add to give you a 12, that would be negative 14, no, positive 14, and negative 2 would multiply to give you negative 28 and add to give you positive 12. And the last one have to be b and b, and you're looking for two numbers in here that multiply to give you negative 20 and add to give you negative 1. So that would be, they multiply to give you negative 20 and add to give you negative 1. That would be negative 5 and 4. So that would be b minus 5 and b plus 4. And again, you can do a quick check of multiplication to make sure that you got the right answer. B times b would give you b squared, and then you'd have plus 4b minus 5b would give you together, add together, give you negative 1b, and then you got the negative 5 times the positive 4, which will give you the negative 20, so that you will get what you started with back. Okay, the other type of factoring that we need to go over is the ones where you have something in front of the x squared that's not 1, and it's not a GCF that can be factored out. So with these ones here, you would again, if we use what's called the decomposition method. You usually use the decomposition method, or sometimes people use the box method. So I'm going to stick to the decomposition method. I typically like to factor by guess and check, but most people like the decomposition method, so we'll just stick to that for now. So if there's something in front, when you're looking for the two numbers that multiply, you'd be looking for two numbers that multiply not to give you negative 10 anymore, but you'd be looking for two numbers that multiply to give you negative 10 times the 3 that's out front, so that would be negative 30. And they have to add to give you this term in here, the middle term, which is negative 13. So two numbers that multiply to give you negative 30 that add to give you negative 13 would be negative 2. I was going to say negative 3, negative 10, but that would give you positive 30. So you want multiply to give you negative 30. So that would have to be negative 15 and positive 2. So for decomposition method, I usually like to say your steps are find the numbers, which is the step we just completed. And the next step would be to break it down. Next step is group and GCF. And then the last step would be final factors. So find the numbers, break it down, group and GCF. Find the numbers, break it down, group and GCF, and then your final answer. Alright, so we found the numbers, negative 15 and 2, so now we're going to break it down. So 3s squared minus 15s plus 2s will add to give you the negative 13, so you're just basically breaking down negative 13 into negative 15s and plus 2s, and then you still keep the last term the same, negative 10. So we've found the numbers, we've broken it down, now we're going to group the first two, group the last two, and take the GCF out of each group. So the first two terms have a GCF of 3s outside of s minus 5. I don't like using s as a variable because it looks like a 5 when I try to write it. Okay, so the next set of terms, 2s minus 10, if you look at both of those, there's a GCF of 2, And what would be left inside when you take this, the 2 out of the first term would be s, and 10 divided by 2 would be a 5. Sorry, the s's look so much like 5s there, but anyway, if you look at both of those groups now, they both have an s minus 5 as a factor. So that s minus 5 kind of comes out as a GCF, and you're left with, when you take the s minus 5 out of the first group, you're left with 3s. And when you take the s minus 5 out of the second group, you're left with plus 2. So those would be your factors. And you can check s times 3s gives you the 3s squared, and then the outside and the inside would be 2s minus 15s, which would give you the negative 13s, and then the last terms, minus 5 and 2, would give you the minus 10, so you've done it right. The next one, you'd be looking for two numbers which multiply, so using the steps again for decomposition, you know you're going to have to use decomposition because there's something in front. Oh, well, before we do that, I just realized there's a GCF there that we can factor out, because 6 and 21 and 9 all have a common factor of 3. So we can take that out first and make the numbers a little bit smaller to work with for factoring the remaining trinomial. So 6x squared divided out the 3 gives you 2x squared minus 21 divided by 3 is 7x, and 9 divided by 3 is 3. So now we'd be factoring this here, which would be looking for, find the numbers which multiply to give you 2 times 3, which is 6, and add to give you the middle term, which is negative 7. So two numbers which multiply to give you positive 6, and that means they both have to be positive or both have to be negative. But if they add to give you a negative 7, that means they must both be negative. So two factors of 6 that are negative that multiply to give you 6 but add to give you negative 7 would be negative 1 and negative 6. So we think our little kind of steps up here, find the numbers, break it down, group and GCF. We found the numbers, now we got to break down the middle term. And I'm going to keep that 3 out front because it's part of the factors, but we're going to factor the inside trinomial by breaking down the negative 7 as negative 1x minus 6x plus the 3. And then we're going to find the numbers, break it down, group and GCF. So then, I'm just going to put big brackets here for a minute. So out of this set of terms, the first two terms, there's only an x in common, and you'd be left with 2x minus 1. And in the second set of terms, the first term is a negative, so we factor that negative out along with a 3 that's a GCF. So then the negative 6x divide out the negative 3 gives you positive 2x, and then the 3 divided by negative 3 gives you minus 1. I'm just going to close off those square brackets there. So now I've got inside here, I've got this group and this group both have a 2x minus 1 that can come out. And when you take the 2x minus 1 out of the first group, you have left an x left. And if you take it out of the second group of terms, you have a minus 3 left. So there would be your factors. Okay, the next one is also another trinomial, and because trinomial means 3 terms, and the 8 would not be able to come out as a GCF, and there would be no GCF for any of the 3 terms, so we're going to have to use decomposition again. So we'll be looking for two numbers that multiply to give you 24 and add to give you negative 14. So if you think about the numbers that multiply to give you 24 and add to give you a negative 14, that would have to be two negative numbers, so that would be negative 2 and negative 12. Would have to multiply to give you positive 24 and add to give you negative 14. So find the numbers, break it down. So the 8r squared minus 2r minus 12r plus 3. So find the numbers, break it down, group and GCF. So take out the first group, the GCF would be a 2 and an r outside of 4r minus 1. And the second group would be minus, and 3 is common to both those. It would be 4r, 12 divided by 3 is 4r, 3 divided by negative 3 is minus 1. Then you can see that that's the same thing for both sets of terms. So that kind of comes out as a GCF, 4r minus 1. And you're left with, when you take it out of the first group of terms, 2r, and you take it out of the second group, you're left with just a minus 3, which are your factors. And the last one here, you'd be looking for two numbers which multiply to give you negative 30, and add to give you positive 1, which would be 6 and negative 5. So then you find the numbers, break it down, group and GCF, follow those steps. So 6d squared plus 6d minus 5d would be, my arrows are kind of pointing to the wrong thing here. So that would be basically breaking down the d by using 6d and negative 5d. And then you still get your minus 5 on the end. Then you find the numbers, break it down, group and GCF. So 6d is the GCF of the first group, and minus 5 would be the GCF of the second group. It would be d plus 1 again left inside. And then this group and this group would both have a d plus 1 that can come out, and you'll be left with 6d minus the 5. So that's factoring trinomials, the two types, the easy type and the harder type, which requires decomposition. And the last type of factoring is my personal favorite in factoring, difference of squares. So basically, difference of squares is when you have something that can be written as a perfect square minus a perfect square. And those factors would always be of the type square root of the first term plus square root of the second term times square root of the first term minus square root of the second term. So this one here has that pattern, so its factors would be x and x, and square root of the second term would be 3 and 3, and one would have a plus and one would have a minus. And the second one also has that pattern of 2x times 2x, 5 times 5, so it would have factors 2x plus 5, 2x minus 5. And the last one, again, that would be 6x times 6x, 1 times 1. So that would be 6x plus 1. I hope my dogs didn't frighten you. But it's hard to start this over again because every time they always keep barking. Okay, so that would be your difference of squares. It's supposed to be a plus sign there. Alright, and the other type of factoring basically is combination factoring, which involves more than one type. The first rule of factoring is always check for a GCF first. And try to make what's left a little bit easier to factor. So the first one there would be a 5 as a GCF, and then you'd have x squared minus 11x plus 10. Which inside there is an easy trinomial now. So if that factors, it would have to have two factors, x and x, to give you the x squared, and the numbers that go here would be the numbers that multiply to give you 10 and add to give you negative 11, which would be minus 10 and minus 1. So if you check, that would be, and multiply that out, you get x times x is x squared, minus x minus 10x, and then plus 10, which is what we wanted. Alright, and the second one has a GCF of 3, so you'd have x squared minus 42 divided by 3 is 14x, and 72 divided by 3 is 24. So again, what's left inside is a trinomial, and it would be an easier trinomial, so you don't have to use decomposition. You would have x and x to give you the first term of x squared, and the last two terms in your factors would have to multiply to give you 24, multiply to give you 24, and add to give you negative 14, which would be, that should be an equal sign, multiply to give you 24 and add to give you negative 14, which would be negative 2 and 12, negative 12. So that would be minus 2, minus 12 would be your factors. The next ones here, Again, there's a GCF of 2 that can come out, and you'll be left with 2x squared plus 11x plus 9, which is a trinomial again, left inside there. And if it is factorable, you'll be looking for two numbers which multiply to give you 2 times 9, which is 18, and add to give you 11. And those two numbers would be 9 and 2. So now we're going to go down another step, and this time we're going to break down the middle term 11x using those two numbers. So plus 9x plus 2x instead of 11x. And then we're going to group and group. So we still got to carry down the 2 that we took out as a GCF first. And in the first group there is a x that can come out, leaving you with 2x plus 9 inside. And the second group, there's nothing in common, so when there's nothing in common, we take out a 1, leaving you with 2x plus 9 inside. So that gives us 2x plus 9 outside of x plus 1, because that 2x plus 9 comes out, and you're left with x plus 1. And you don't need that extra set of brackets that I have there, so I just took that out. Alright, so solve, oh, I missed the last one here. So the last one here would be, first again, check for GCF, and 9 can come out. And you're left with 9x squared minus 1. And if you recognize this inside here as a difference of squares, then you can factor that as 3x and 3x plus 1 and minus 1. Okay, so just a couple little notes there. Recall solving an equation in standard form, ax squared plus bx plus c equals 0, is the same as finding the x-intercepts of the equation y equals ax squared plus bx plus c. And finding the zeros means to find the value of the variable that makes the value of the function equal 0, which is similar to finding the x-intercepts. And determining the roots means to find the values of the variable that make the equation true. So you can always check your answers though when you're finished by substituting your answers back into the equation. So now we're going to go into a few methods of factoring to help you solve an equation, and we'll learn a few other another method later on in the chapter. So suppose you're given an equation of the form, in factored form, 3x plus 1 times 2x minus 5 equals 0. How could we solve this equation? Well, that would involve using a very important property called the zero product property. And the zero product property says that if you have a product of two things and the answer is 0, the product of those two numbers is 0, then that will only happen if one of the things in the product has a value of 0. So either A is 0 or B is 0. So, or both are 0. So basically you would take the two factors. If something is written in a factored form, that means it's in a product of two factors. So if the product of those two factors is 0, then one of those factors has to have a value of 0. So you would just basically set each of the factors equal to 0 and solve to get your answers. And again, this method will only work if you have a product of factors equaling 0. It's different than 0. You'd have to multiply it all, bring to everything to one side, and make it equal 0 before you can use factoring to solve. So the first few examples now already have them factored for you. We're just going to quickly solve them. So if you've got something times something is 0, that means either x minus 4 has to have a value of 0, or x plus 7 has to have a value of 0, which means x is 4 would be one solution, or x is negative 7 would be another solution. So if you go back and check, they're basically the opposites of the numbers that are in the factors, right? And if you plug 4 in for x here, you get 4 minus 4, which is 0, times 4 plus 7, which is 11, and 0 times 11 would be 0. If you plug in the negative 7, you want to go back and check. Negative 7 take away 4 would be negative 11, but negative 7 plus 7 in the other factor would be 0. So negative 11 times 0 results in 0. So they would both be solutions. The second one is in the form of a product, 3x times x plus 12 equals 0. So either 3x has to have a value of 0, or x plus 12 has to have a value of 0. Now I'm writing all these steps out now, but eventually, once you get to the factored form, you might be able to just look at the factors and tell that the first one would just give you an x of 0, and the second one would give you an x of negative 12. Those would be your two solutions. So C is not factored for you already, but it's an easy trinomial to factor. It would have x and x, and two numbers that go here would have to multiply to give you 24, but add to give you negative 11, which would be minus 3 and minus 8. So now I've got it in a factored form. X minus 3 times x minus 8 is 0, so therefore either x minus 3 is 0 or x minus 8 is 0, which means x would have to have a value of 3 or x would have to have a value of 8. You're just solving that little equation. Alright, so the next example has a difference of squares. So that would have factors 3x plus 7, the square root of 49 is 7, and 3x minus 7, which means either 3x plus 7 is 0, or the other factor, 3x minus 7, has a value of 0, which means 3x equals negative 7, which means that if I divide both sides by 3 now, I get x is negative 7 over 3, so that's one solution. And then this one, if I solve for x and keep the x's on one side, number over to the other, because you add 7 to both sides there, and then divide both sides by 3. Page number is in the way. So then I basically get x is positive 7 over 3. Alright, the next one requires using decomposition, so because 2 is not a GCF, so if I factor this, I'm looking for two numbers which multiply to give me 2 times 5 is 10, and add to give me 11, and that would be 10 and 1. So if I break down the middle term, I get 2x squared plus 10x plus 1x plus 5, and then take the GCF out of each group, so it'll be 2x outside of x plus 5 plus 1 outside of x plus 5, and then I've got these two groups here, both have x plus 5 in them, so if I take that out, I'm left with just the 2x plus 1 as my other factor. So now I've got the expression or the equation written in a product as a product equal to 0. So that means that something times something is 0. Means that either x plus 5 has to be 0, which means x is negative 5. Is one solution. Or the other factor has to be 0, which means 2x has to equal negative 1, x has to be negative 1/2 if I divide both sides by 2. A quick way to get the factors is, the solutions from the factors is just take the opposites. If this is x plus 5, then you know your answer is going to be negative 5. And if this is 2x plus 1, you know your answer is going to be negative 1 divided by what's in front of x, so negative 1 divided by 2. Okay, the next example, I remember from class there's a mistake in this. This doesn't factor with the plus 4, so that has to be minus 4. So when I'm factoring or solving an equation, I like to have a positive x squared term, because the two methods that you're going to be using for the most part are solving by factoring or solving by what we're going to learn later is quadratic formula, and both of them have, you bring all terms to one side equal to 0 to start. And again, both of those methods, I would prefer to have a positive x squared. So I would bring the negative 3x squared over to this side, and that would give me positive 3x squared minus 11x, and that 4 stayed on that side, minus 4 should be there. So if we're factoring this now, we got to use decomposition because the 3 that's in front of x squared cannot come out as a GCF. So we would be looking for two numbers that multiply to give you negative 12 and add to give you negative 11. And In this case, that would be negative 12 and positive 1. So negative 11x gets broken down as negative 12x plus 1x, and then we still have the minus 4. So find the numbers, break it down. Now we're going to group in GCF. So the first group has a GCF of 3x outside of x minus 4. And the second group has nothing in common, so we take out the 1, and we'd be left with x minus 4 inside, and that x minus 4 comes out, and you're left with 3x plus 1. So that's equals 0. So you've got a product of factors equaling 0, so therefore either x minus 4 has to equal 0, or the 3x plus 1 has to equal 0, which means x would be 4 if I'm solving that little equation, and if I'm solving x in this equation, I'm going to get the opposite of 1, which is negative 1, and then divide by what's in front of x. So it's going to be x equals negative 1/3. So there are my two solutions. That's a negative, by the way. It looks like it's just a line, but it's actually a negative. Negative 1/3. It's pretty sad looking 1/3, isn't it? Write that again. X equals negative 1/3. All right, example 2, state the zeros for f of x. Well, the zeros are the values of x that make the equation equal to 0. So we would be solving this equation equal to 0. So again, we can use factoring again and it's an easy trinomial, and because there are two numbers that multiply to give you negative 12 and add to give you negative 1, and that would be negative 4 and positive 3. So therefore, x minus 4 should equal 0, or x plus 3 should equal 0, because again, you have a product of two things equaling 0. One of those things has to be 0. So if you can come up with a solution of x equals 4 without writing this step in, that's fine. And this one here, again, would be, if x plus 3 is the factor, x equals negative 3 is going to be the solution. You can always go back and plug those values into your equation and show that they do give you 0 when you plug them in. Okay, in example 3, find the roots. So this here is not set up equal to 0, so the first thing I'd have to do is simplify this equation by expanding this side to 3x minus 6, and then bringing all terms to one side. So 2x squared plus 2x minus 12, and then if I bring the 3x over, it becomes minus 3x. I bring the negative 6 over to the other side, it becomes plus 6. So if I put like terms together, I've got 2x squared, 2x and negative 3x is minus x, and then I've got minus 12 and plus 6 is minus 6. So if this is able to be solved by factoring, I would have to come up with two numbers, because the 2 in front is not a GCF, so I'd have to come up with two numbers that multiply to give you 2 times negative 6, which is negative 12, and add to give you negative 1, the coefficient of the middle term, and that would be negative 4 and 3. So find the numbers, break it down. So minus 4x plus 3x, using those two numbers that we came up with, and then minus 6 equals 0, and then we group the first two, group the last two. We've got 2x outside of x minus 2 plus 3 outside of x minus 2 equals 0, and then you factor out the x minus 2, and what's left is 2x plus 3. So that means that either x minus 2 is 0, or 2x plus 3 is 0, which means x is 2, or 2x is negative 3 divided by the 2, which gives you x equals negative 3 over 2. So those are the two solutions for that. X is 2 and x is negative 3 over 2. Example 4 is kind of putting it into a word problem. It says the dimensions of a garden in meters are given by the roots of the quadratic equation x squared minus 3x plus 250 equal to 0. Solve the equation to determine the length and width of the garden. So the only way you know how to solve so far is by factoring. So if we're going to factor that, you'd have to come up with two numbers that multiply to give you 250 and add to give you negative 35, which would have to be negative 25 and negative 10 would multiply to give you negative 250 and add to give you negative 35. So we don't need to do decomposition here, sorry. We can just go straight to the factors because it's a easy trinomial. So that would have to be x minus 25 and x minus 10. If you multiply that, it will give you the equation x squared minus 35x plus 250 equals 0. So therefore x minus 25 is 0, meaning x is 25. Or the other factor has a value of 0, meaning x is 10. So the length and width of the garden, there are two possibilities. If x is, there's two possibilities for x. So 25 by 10 would have to be the dimensions of the garden, because it says the dimensions are the roots and they would be the roots. Next example gives you an equation to represent the height of the soccer ball kicked by a player, and it's given by the equation h of t equals negative 5t squared plus 30t, where h is the height in meters and t is the time in seconds that the ball is in the air. How long is the ball in the air? Well, if you think about that for a minute, the ball is in the air until the height is 0. So if we solve for height equals 0, we just replace the h with the 0 and solve that. We should be able to find the times when the height is 0. So again, this is a nice easy one to factor because you can just factor out the GCF of 5t, negative 5t, and then that would be t minus, because positive 30 divided by negative is going to be minus 6. So therefore you got something times something is 0 again, so either negative 5t has to be 0, or t minus 6 has to be 0. And if you solve this, you're going to get t equals 0 seconds, or t equals 6 seconds. And that kind of makes sense because the ball would more than likely be on the ground, get kicked up into the air, and come back down again. So it should be at the time 0 when you start, and it would take 6 seconds before it hits the ground again. So the next word problem describes a rectangle whose height is 2 less than 3 times the width. I'm going to change that to length. Whose length of the rectangle is 2 less than 3 times the width. So if we let w be the width of the rectangle, then the length would be 2 less than 3 times the width. So 3 times the width, take away 2, would be an expression to represent the length. So the area is 40. So area of a rectangle is length times width. So area is 40, we know that, and we know the length can be described as 3w minus 2, and the width can be described as just w. So then if we expand this, we get 3w times w is 3w squared minus 2 times w, and now we have a quadratic equation, which we can bring all terms to one side and set the equation equal to 0 so that we can solve it. This one here is not one that many of you would probably choose to solve by factoring once you know the new method we're going to learn in the next section, which is solving by, well, I think it's next section, solving by quadratic formula. But right now, the only method you know is factoring, so you would have to look here. 3 can't factor out as a GCF, so you'd have to look for two numbers that multiply to give you negative 120 and add to give you negative 2. And that would take a little bit of time because negative 120 has a lot of factors, but just looking at it quickly, I can think negative 12 and 10 would work. That would multiply to give you negative 120 and add to give you negative 2. So then if you break down the middle term, you get 3w squared minus 12w plus 10w minus 40, and then group the first two, group the last two. So that would give you 3w is a GCF, and you'd be left with w minus 4 inside, and 10 would be the GCF of the next two terms, leaving you with w minus 4 inside, which gives you factors of w minus 4 and 3w plus 10. So that's going to give you two solutions. Either w is 4, or if you solve 3w plus 10 equals 0, you get 3w equals negative 10, and then you divide both sides by 3, you get w equals negative 10 over 3. But of course this would have to be rejected because you can't have a negative with. So you'd reject that solution, and the only solution would be that the width would have to be 4 centimeters. So, and I'm just going to run out of space here, but if I come back now, I'm going to cross out my question. I'm just going to move over here. That the width would have to be 4 centimeters, and 3 times 4 minus 2 would be 12 minus 2, which would be 10 centimeters for the, this would be the width, and 10 centimeters for the length. Just plug it back into that to get the length. And the last example talks about when you're solving an equation, one of the methods you shouldn't use is dividing out a variable out of both sides of the equation, because you could possibly lose solutions. So this is the error here, that you shouldn't divide by a variable because you could lose solutions. May lose roots because you're dividing out the x's. We don't know what x is, so you don't know if that's, if you divide it out, you might be losing a solution. So if we take this here, the best way to do this when you have an equation like that is to bring everything to one side. And if you have a situation like here where you could divide x out of both sides, that usually means that if you bring it all to one side equal to 0, that means there should be a common factor. In this case, the common factor is x, and you're left with 4x minus 9 equals 0. So therefore there'd be two solutions. Either x is 0, or the other factor, 4x minus 9, is 0, which gives you 4x is 9, and x is 9 over 4, which is 2.25, the answer they got above. But now we have two answers, 2.25 and 0, whereas when the way Matthew did it, you lost one of the answers. You only got the 2.25. So there's some questions there at the end there that you can try from your textbook related to this now.